Gentlemen, thank you. Right, ladies and gentlemen, thank you very much indeed for coming back from your various lunches in the various locations. One point that I don't think has been made clear, and I feel a bit guilty because the British Interplanetary Society has got an interesting table, or rather a boring table full of interesting things outside, and it's rather tucked back around the way, and I feel guilty because I helped Alistair decide where to put it. So can you please make sure that during the coffee breaks you do go and see his table and buy some of the stuff. The British Interplanetary Society is an organisation which has similar sorts of aims to AMSAT, and it would be really good if we can support it. And in fact, if I'm sure Alistair would love to sign up new members while he's here. So thank you for that in advance. Okay, this session is we swapped it round because we've had one or two technical issues. This session is going to be given by Steve Greenland, who's the system engineer for UKube. Sorry, for no, you're not, are you, Steve? For UKube. UKube-1, for those that don't know, I'm sure everybody does know, is going to be the UK's first national CubeSat. It's got a couple of solitaires around it because it's been built and assembled in Scotland, but we won't wave that flag too much. For those in the room, there is a model here, a full-size model here on the table. And I think it's a rather beautiful model. So do, during the coffee break, come up and have a look at it. But please, it's on loan from the Open University. I have signed for it. It is worth several £100. So please look but don't touch, and try not to bend the antennas. Anyway, as I said, we've had one or two technical issues. Steve has been very, very busy. It's getting to the really critical stage of integration and finalisation of UKube, so he wasn't able to get down here last night as he was hoping to present the paper in person, but through the modern wonders of Skype and everything, hopefully I can call in Steve Greenland in Glasgow.
Hello, receiving loud and clear.
Okay, Steve, it's over to you, and we have a good man called Peter to hit the key when you say next slide, please.
Great.
Currently, we're looking at the first slide, of course.
Fantastic.
Sorry, Steve.
Thank you very much for putting up with me not actually being there in person. Apologies for that, but like Graham says, we're doing a lot of testing at the minute, checking out the operations. So this is UKube-1. As the photo shows, it's in its stowed state at the moment without the deployable arrays deployed or the ISIS antenna system with the antennas out. We have a lot of people to thank for being where we are. Not just Clydespace. The whole AMSAT community has been fantastic. Bright Ascension, the software developers. All the payloads, it's been a real community effort, and that's really what's inspired me to continue to work all the weekends to get this ready for launch. So thanks a lot for your continued support. So onto the agenda, the next slide. What I thought I'd talk about really is just give you a quick overview of UKube-1, where it comes from, perhaps where it might be going in the future. Go through the payloads and some of the enabling technologies, and then just show you some of the photos which I've taken over the course of about the last year as we've been going through kind of the integration and testing, environmental testing, and now the operations rehearsals in preparation for launch. So on to the next slide, which is just a title slide, which I'll go into now. So on to slide 4. So UKube was set up and came from something called the CubeSat Research Network, which unfortunately now doesn't really exist. It sort of survived long enough to give us the momentum to get a first CubeSat recognised by the BNSC, which is now the UK Space Agency, with the idea of developing a national programme in which industries and universities and any other groups such as AMSAT work together to produce a series of missions, producing payloads and platforms and moving through to launch. And we were fortunate enough to work with Astrium, a guy called Ronan Wall, and he encouraged this so much and got us kind of our foots through the door so that we could start building a CubeSat. And so we came up with the initial requirements for UKube-1. This is slide 5. That we wanted to demonstrate new UK space technology. We wanted to show that we could perform some useful science within this type of sized spacecraft. We wanted to demonstrate university and industry collaboration. I myself am kind of a full-time employee of Clyde Space at the moment, but previously I was at University of Strathclyde as a knowledge transfer partner. It will demonstrate education and outreach in STEM subjects, and obviously we're delighted that the FunCube board is in the stack because that provides so many opportunities through your hard work. So I think I'm going to be saying thank you quite a lot through this presentation because it wouldn't exist without so many people. UKube-1 should demonstrate payload kickoff to flight qualified spacecraft in less than 12 months. Well, that didn't really happen. I think by the time we get to launch, and I'll say something about that soon, will be more like what will it be? About 32 months, I would say. So didn't really meet that one. But otherwise, we've met significant parts of this this challenge before reaching the launch pad. So UKube-1 was and is heavily constrained by the resources we have available, the personnel and the timescales that we're working to, with the kind of the shared carrot of a free launch for all the parties involved. It's driven in part by a coalition with expert review by Astrium to ensure that we haven't missed anything or that all issues are thoroughly explored. In March 2011, then we selected 4 payloads from a total of 22 proposals, and these are now three of which are fully integrated into the satellite. From July 2011, then we took over. Clyde Space took over more of the program management responsibility. And so on to the next slide, the baseline orbit. This has changed a lot. But now hopefully won't change again. We are booked to fly on a Soyuz 2 frigate launch in Q3, Q4 2013. The primary payload being a Meteor M, which is a Russian federal meteorological satellite. Should put us into a sun-synchronous orbit about 635, 650 kilometers. It's 98 degrees. With an LTAN of about 2100. From the initial TLEs that I've got from the Russians, and it looks like the first pass will be over the UK. So once we know the exact date, then if everyone can listen, that would be very handy. On to the next slide, the baseline operations. As I've mentioned, we've got these 3 primary payloads on board. These will be cycled in the sunlit period, depending on their power requirements and the amount of data that they produce. We have some which are very high power but produce very little data. Others which are kind of low power, high data. So we've got a plan to balance all that, and we've been focusing on that really in this period when we've been defining the operations to make sure that we get the maximum that we can out of the satellite. We have active magnetic attitude control, so basically just BDOT control, which will switch into a sun tracking mode to maximize the power that we can get. We have the 2 transceivers on board. The UV transceiver from ISIS, which will be sending packets when it's over the UK, and possibly South Africa as well. We're talking to CPUT whether or not they can enable anything there. Then we've got the FunCube transceiver, which obviously is payload in itself. It's also a very valuable backdoor into the system. So if there are any issues which need recovery through a secondary system, then we have that capability. an S-band transmitter, which is mainly for demonstration purposes, but once proven could be very valuable for future missions in terms of getting down things like images from space. And then a electric power system and power system basically as standard Clyde space parts. So I'm sure that you've all seen this slide before, slide 9. It shows kind of the standard stack configuration for CubeSats with a standard 104-pin header and various PCBs stacked together, which allows us the capability to build the satellite relatively quickly. Although we found that we can build the stack itself within a few hours, but getting the wire harnesses to the solar panels and things is what really takes the time in building. So on to slide 10, just the general architecture. There's this central PC-104 bus, which interfaces towards all the main internal subsystems, which then has links out to things such as the solar arrays, the solar array deployments, and various sensors and actuators which are mounted on the panels. I'll skip through now to slide 12, which shows the first of the payloads. This is from Open University, who have also produced that lovely model that you've got down there. And it's primarily it's about radiation damage monitoring of CMOS technology, but it also flies an imager with which we can hopefully take some reasonable images of the Earth. We've been trialing that last week, and we've taken some images, so good news there. And also as a technology demonstration of this type of technology for future ESA missions like the Jupiter Icy Moons. The next slide shows TopCat, which is from Bath University, and this uses the GPS signal to look at the shifts in the two frequencies, and we can tell something about the ionosphere from that. We also looked at linking that with the ADCS. However, that link is probably not going to be operational for launch. On slide 14, we've got Janus, which is from Astrium. It's a random number generator based on the space radiation. It has applicability to kind of telecoms satellites where random numbers will be used for encryption. And it also shows the use of a non-space grade SRAM FPGA, a Xilinx FPGA, which obviously Astrium is a big step for Astrium to start looking at whether they can use non-space grade parts in space. So on to slide 15. Another company based up in Glasgow is Bright Ascent, and Steepest Descent. God, I hope they're not listening. Steepest Descent, and they've produced a new type of computer for us, which is FPGA-based primary processor, and then a smaller secondary processor based on kind of a more common CubeSat microprocessor called an MSP430. It is radiation tolerant by design, and that's been reviewed by some of the engineers at Astrium to ensure that we kind of maximize the tolerance of using these off-the-shelf parts in the correct way. And that's really now becoming a commercial product. We've been talking to various different mission teams about kind of other flights post UKube-1, and I'd say that they're actively looking for partners to kind of develop this further. On to the next slide. This, I'm sure, is one that you will know all about, so I'll say very little apart from how fantastic it is as an opportunity to transmit and be received in classrooms across the UK, and also the feature that we can implement now, and last week we spent a lot of time testing, is this backdoor capability. So we can use this transceiver to control the spacecraft should we need to in an off-nominal case. We have deployable solar arrays, which are kind of part of the technology development program at Clydespace, really to maximise the amount of power that we can get, so we can leave the payloads on for as long as possible, and hopefully that will mean that we'll be able to run them in Eclipse as well, once the payload budget's been checked out. We have, again, more technology development for Clydespace in developing the attitude control systems, which in turn link into future projects and products, which are the reaction wheels. So a lot of it is sized so that then in the future we can drive more high performance attitude control systems. We have S-band transmitter from Cape Peninsula University of Technology, which is out in South Africa, and they're producing all sorts of new radio equipment for CubeSats, and this is kind of the first of them. It's been a great kind of partnership in getting it to this state, with Clydespace technicians kind of working with the SEPA engineers to get the systems built. In the process, we've learned a lot about RF. I have to admit that I am fairly ignorant of RF, and it's been an eye-opening experience listening to the insight from some of your guys when they come up and teach us these things. Lastly, we've got onboard software, which is developed by Bright Ascension. It's based in FreeRTOS, which is a real-time operating system. That's fairly innovative for these types of missions. We are suffering a little bit from that in our testing at the moment. One of the largest challenges, which hopefully we'll be overcoming and is now fixed, is the how to schedule all the tasks to ensure that they definitely happen at the right times. It's CCSDS, which is an ESA standard compatible with the packet utilization software scheme, which is kind of an add-on which allows you to kind of reference specific procedures and things, with obvious operations like onboard scheduling and file-based data transfers. Throughout all this time for Clydespace, then it's really been just about developing systems. So the next slide 21, just shows some of the support equipment that we've been developing. In particular, I'm kind of interested by the idea of the payload interface emulator, which is on the next slide in more detail, 22. In encouraging and providing a platform for rapid development for payload teams whilst the platform is still in development, and I think we use that as well as we could, although there's obvious improvements that we can make to it in the future. Okay, so that's kind of all the things which are going on board. Now is sort of more picture based, which is just a series of images from really the process. I don't think you would have seen any of these last year. I think that they all come from just kind of post the last colloquium. So at the end of 2011, then we'd really kind of gone through an initial iteration of the design. We'd done some vibe tests, we'd done parabolic flight tests. A lot of the subsystems were already delivered and checked out. And we were really waiting for knowing exactly when the launch would be, because obviously it's very hard to motivate people to deliver anything when you don't have a final launch date, and trying to ensure that the system remained fairly consistent across. At the bottom, I don't know whether or not it comes out on your slides or whether it looks a bit of a mess, but those are all the various different launch opportunities that we were either slated in for or spent a lot of time investigating, and how that shifted. So we went from Dnepa to PSLV to Soyuz, back to PSLV, and then back to Soyuz again. So that was it's been an experience in terms of learning exactly what the pitfalls are in this launch procurement process. So at the beginning of 2012, then we started to integrate the payloads into the stack. We made sure that we had that the testing, which up until that point had been done with this interface emulator, matched the systems as they were installed, and that went reasonably smoothly. It was certainly a learning process in terms of how to deal with lots of payload teams delivering parts, how to test them efficiently and quickly. I think we learned a lot about requirements for ease of test, which we should have put into UKube and will be doing in the future. We took ownership of all the subsystems at this point. A lot of them had already been delivered as EMs, or indeed some were ready as FMs before this. But we went through, we held workshops with a number of the suppliers, so that we got a real understanding for all the different systems as they were developed. We then moved into kind of the end-to-end testing, so setting up the first ground station with the help of Raoul and Mike, if he's in the audience. Did great work doing the demodulation. We kind of tested all that and then sort of set it aside, which is probably a little bit of a mistake, and something that Graham had been telling me definitely don't do, because it was so easy to use the umbilical to do all the testing, but it's not the same. And we're now back to the state where we do all of our testing wirelessly, and that's working perfectly. So, yeah, lessons learned there. We had the system integrated. At this point, lots more wires were added, which is now kind of the challenge in terms of fitting it all in. The systems themselves, you can see there's still some space in there that we could fly extra things, but just getting the harnessing around that into the solar panels is what was very difficult there. And so perhaps looking for ways to improve the harnessing architecture for future missions and how the structure can support that as well. We did various thermal cycling, this is slide 29, and deployment tests in thermal to make sure that our new systems were working well. We also got artwork put on the solar panels. Yeah, thermal vacuum. We went down to Astrium to perform the thermal vacuum tests, and at exactly the same time, something happened to our test computers. It was some sort of update from Linux or Ubuntu even, and the serial drivers, some obscure setting in one of the serial drivers, we believe, got changed by this, and so we wasted about 2 days in thermal vacuum, which is probably the worst time and the most expensive time to try and debug this problem. But we learned from it, and we now have a fully characterized kind of test setup, which we can recover very easily now from those kind of failures. RF patterns. The RF testing was where we learned how little we did know about RF, and one of the challenges that we encountered was that we had a faulty harness which we had manufactured, and so although the patterns looked great, they were about 60 dB lower than they should be, which caused quite a lot of panic, which we've since retested. And learned more about what we don't know, which was multipath effects and how to properly cancel them. But we've gone through all of that now, and we've got a very high level of confidence in the RF system. Next up was the vibration test, and that went absolutely fine. That was probably the smoothest of all the testing. Nothing fell off. Launch meeting. We then went out to Russia in the end of March this year, in which it was still kind of meters of snow everywhere. That's me doing a star jump outside the Buran in Gorky Park, I think it is, and that was a fascinating insight into how launches are actually arranged. and the amount of meetings and somber dealings that have to go on behind the scenes. We then, around the same time, we were doing the flight readiness review. Lots of documentation. So thanks for everyone who helped with that. We had about 117 review item discrepancies, so kind of technical queries from Astrium, including 30 that they kind of dropped on us just the night before. But we got through it after we had a FRR closeout just a couple of weeks ago. So all of those are now resolved, and we're really focusing on operational checkout, which we'll then review at the pre-ship review, making sure that we've really understood how the satellite functions and is characterized, so then once it's in orbit, then any kind of strange behavior, we can say, oh yes, we saw that sort of a couple of weeks ago. You don't need to panic. So we had a launch date, 1st of July. I was told that we had a launch window on the 26th to 29th of October. But then on the early hours of the 2nd of July, we had this proton failure at Baikonur. But we're still aiming to deliver for the 26th to 29th of October until we learn otherwise. What would happen is really we would probably be in a state where the satellite's sitting there. Hopefully we can encourage people to practice with operations and just spend a bit more time kind of further characterizing it. So really the main emphasis at the minute is operations. We've gone through the vast majority of all the major operations, documented them, captured exactly what we expect to see, how all the different payloads operate. And we'll be doing a third kind of rehearsal session towards the end of this month. There's kind of this has been great in terms of recovery. So thanks to Graham and Phil and Duncan and everyone who was involved on your side for getting that in. We have Helen Walker from RAL, who's the mission manager, and has been learning all about kind of the interesting features of the satellite. So slide 37 really. UKube hopefully it's been extremely influential to Clyde Space in terms of our learning, understanding exactly how satellites can be brought together, and hopefully it will lead into future UKSA programs. UKube-2 is being talked about, and we would hope that kind of the lessons learned from UKube-1 will be strongly informing the future kind of CubeSat strategy. We have experienced many of the same issues in a traditional satellite program, trying to bring together all of the diverse stakeholders, trying to make sure that everyone is synchronized in terms of delivery, and of course launch delays and more launch delays and more launch delays. But 38, just to say thank you, because UKube-1 really is a community effort. It's so inspiring to me to have everyone's enthusiasm and positivity when I need it. So thank you all, and especially thanks to any of the RF maestros who are around. Thanks to Howard and Mike and John and Darcy. So the last slide is one that Graham found for me, which is slide 39. Whenever I'm wondering whether or not all of this seems a bit like I'm hitting my head against a wall, and it's all a bit deja vu. And then Graham finds this photograph of a mysterious Martin Sweeting with an equally mysterious Steve Greenland working on USAT-1. So.
Okay. Okay, Steve, thank you very much indeed for that. Skype worked very well. You dropped out for about 5 seconds. We held our breath and prayed, and it worked. You came straight back. So any questions for Steve from the audience or from the internet as well? Hand up there, Jim Heck.
Steve, it does seem that you're sort of now getting towards the end of the development of the spacecraft itself and looking forward to the launch. I'm just wondering whether you are going to facilitate or expecting people listening, or radio amateurs in particular, listening to the downlinks, particularly the ISIS transceiver, when it's not over either South Africa or England. Will it indeed be switched on? And do you know if the frequencies and telemetry format and stuff are going to be published? So I don't think we've seen anything yet.
No, we haven't released that yet. In part because until we've kind of finished the operations rehearsals, then there's kind of minor tweaks that we're making to things like the telemetries. The basic operations is that it'll be in a beacon mode, Morse code mode, when it's not operating in a pass over the UK. That be obviously published and hopefully easy to have. I might have lost you. Can you still hear me?
Yeah, you're breaking
yeah.
up slightly.
Okay.
Keep going.
I got a warning flashing up that the internet was going down at Clyde Space. That's a regular occurrence. I think it's the unfortunate fact that we're at the end of Glasgow, and probably there's a dodgy wire somewhere. But where was I? Oh yes, passes. So the basic idle packets, I would expect that we'll publish them. The software that Bright Ascension has made as well does have the capability to be released in a receive-only way, and potentially there'll be a reduced version of that available. But I wouldn't like to. They're working flat out as it is, but we'll see what we can do there.
So, question from the internet. UKube-1 is seen as a pathfinder mission for the agency's proposed national CubeSat program, with one mission every 18 months. Is that still the case?
I very much hope so. Yeah, we hear lots of positive feedback from the agency in this, and yeah, we just look forward to supporting that in the future, especially in terms of lessons learned with this one.
Can you hear me now? Okay. Yeah, we were hoping to be able to show a live picture from the clean room. I'm sorry, Steve, it seemed to drop off about halfway through your presentation there. So we'll get that back up and maybe show it tomorrow. So there's an AMSAT-UK laptop in the clean room, which is doing a number of things, decoding telemetry, but it's also conveniently got a camera in the lid. So when Steve very kindly points it round to point at the flight model of UKube, we get a really good picture. So if there are no other questions, I think we should let Steve get back to work. He's obviously got an awful lot still to do. There's no pressure, Steve, but there's 50-odd people in the room here and many more on the internet who are wishing you every possible success and hope and anticipating being able to hear the signals from UKube real soon now. I have to say that you probably weren't watching the web stream this morning, Steve, but Martin Sweeting was actually a bit more pessimistic than I think you were about the launch date. He made comments that suggested that the Proton actually landed on the launch near the launch pad that you would be using. So I give you that information for what it's worth. A bit of gossip, gossip from Surrey.
That.
You've heard that. Okay. Well, a quick a round of applause, please, for Steve.